3.2 complex numbers. There are a bunch of number systems, and we're going to get into the largest number system, which is going to be complex numbers. A nice Venn diagram shows complex numbers contain all the other number systems. And so, for example, you start with the naturals or the counting numbers, add 0 to it, now you have whole numbers. Now you have plus or minus whole numbers, integers. Now you have rational numbers, which can be written as a ratio. They can be terminating or repeating. Real numbers are the ones on the number line, which include square roots and numbers like pi. And then on the outside of that, you have complex numbers. And inside complex numbers, you have real numbers and imaginary numbers. Imaginary numbers, you can have pure imaginary numbers that have 0 in the form. But importantly, the complex numbers are usually written as z is equal to a plus bi. And this would be mostly the real form, and this is the imaginary form. Now, if a is 0, it's just going to be a pure imaginary number, which would be like 6i or negative 4i. Going down into imaginary numbers, before when you tried to take the square root of a negative number, you couldn't, so it was undefined. However, if you're within the imaginary complex number system, this equals the imaginary number I. Now, just a quick point on what I equals. I equals the square root of 1. Now, if you square it, the square root of negative 1 times the square root of negative 1 looks like this, which is going to equal just negative 1. And if you cube it, it's the same thing as I times I squared, which is, let's see, if I squared is negative 1 times I, you get negative 1 times I, which is a negative I to the fourth is the same thing as I squared times I squared, which is equal to negative 1 times negative 1, and that equals 1. And this is actually going to repeat itself. So I to the fifth is equal to I to the first times I to the fourth. I to the fourth is 1, so it's really equal to I, which is the same thing as this. I to the sixth equals I to the second times I to the fourth, which is really equal to negative 1, and it's going to continue in groups of 4. So that's one thing you can do with imaginary numbers. Another thing you can do with imaginary numbers is just find the square root. So this, if it didn't have the negative inside the radical, it would just be equal to 2. But because it's really the same thing as negative 1 times 4, that is equal to 2 times the square root of negative 1, and we know that this is I, so that answer is just 2I. Similarly, this is equal to 4 times negative 3, so 4 comes out as a 2, and negative 3 is the same thing as negative 1 times 3, so negative 1 comes out as an I, leaving a 3 behind. In this problem, you could take out the negative 1 right away and say it's I, because the square root of negative 1 is I, and then the square root of 36 is just 6, negative 6I. Let's see, the last problem, 2. This is equal to, you can break it down, negative 1 times 9 times 6. I do it this way because this is a perfect square factor, and therefore this comes out as an I, this comes out as a 3. So it's 3I times 2, 6I square root of 6. Now you can also do other parts. So finding the x and the y of this equation. Just know that you have an x gets related with the first number and a 3 gets related with the y. So these are kind of matching up the parts of the two equations because they're in the form a plus bi. So x is equal to 9 and 3 is equal to y. Similarly, you can say, all right, how do I solve for my 2x? Well, negative 2x equals 9, x equals negative 9 halves, and then looking at the y part, I'm going to have 4y equals 3, therefore y is equal to 3/4. Again, equating the similar parts and then solving for x and y. You can also add and subtract complex numbers. All you're doing here is combining like terms. And you're treating I as a specific term. So back to here, 8 plus 5, 13, negative I plus 4I, positive 3I. 7 minus 3 is 4. Be careful here because you have minus negative, which means that it becomes a positive 6i, so that becomes 4 plus 0i, which is just equal to 4. A good idea on these types of problems, because I see so many mistakes, is to distribute that negative through first and then combine like terms, which gets you back